Now consider this situation. You're able to assign your clients to one of two categories before you provide an intervention. You provide the intervention, and then you assign your clients to categories again afterwards. What you'll wind up with is something called a contingency table, where you can divide your clients into four categories based on whether they started in the desired outcome category and whether they ended in the desired outcome category. And what we're interested in is, does the intervention make it more likely that your clients are going to end up post-intervention in the desired outcome? This puts us in this part of the flowchart. We have pre and post intervention data, and we're dividing clients into categories, which makes it nominal. The hypothesis testing approach uses McNemar's test. Our null hypothesis is that if we had an infinite number of clients, the actual difference from pre-intervention to post-intervention would be lower, so that fewer clients would actually end up in the desired category after the intervention than before. The alternative hypothesis is that the number of clients who end up in the desired category after the intervention is greater than the number of clients who start in the desired category. And our p-value that we get from McNemar's test gives us the probability that if this is actually true, if our intervention makes people less likely to wind up in the desired category, that we would have seen the data that we saw. And if our p-value is less than 0.05, we say that it's statistically significant, that it's very unlikely that we would have seen the difference that we saw, the change from pre-intervention to post-intervention, if this null hypothesis was true. The alternative approach is to use odds ratios. And in this case, we're using the odds ratio of correlated proportions. And looking at our contingency table, we've got four groups of people. The people who started and ended in the desired outcome, the people who started and ended not in the desired outcome category. And what we're really interested in are the number of people who, before the intervention, were in the desired outcome but ended up outside of the desired outcome category, and the number of people who started outside the desired category and wound up in the desired category. And our odds ratio for how likely it is that somebody is going to wind up in the desired category versus winding up not in the desired category is this ratio. The clients who changed from the other category to desired over the clients who changed from the desired to the other. And what this is telling us is, if our odds ratio is 1, that means that our intervention does not make clients any more or less likely to end up in the desired category. If the odds ratio is less than 1, that means that our intervention actually makes it less likely, decreases the odds that somebody is going to wind up in the desired category. What we really want to see is an odds ratio greater than 1, which means that our intervention increases the odds of somebody winding up in the desired outcome category. We can also look at the confidence interval of the odds ratio. And what we really want to see is an odds ratio greater than 1 and the confidence interval also greater than 1. If we have an odds ratio and confidence interval that includes the value of 1, then we can't say with 95% certainty that our odds ratio is greater than 1. The worst thing we could see is an odds ratio less than 1 and the confidence interval being less than 1, which means that we're 95% sure that our intervention decreases the odds of a successful outcome.